All right, so last time when you left, we had talked about this slide a little bit. We left it a little bit incomplete, and I totally realized that my numbers that I filled in don't match exactly what I worked with you before. Okay, that's fine. I'd like for you to just take a look at the numbers that you do have. And depending on how careful you were when you set up your slope, also probably depends on how your slopes here in these two columns actually look. But regardless of how they look, they all are approximately equal to what? 2. Your values should look like they're getting closer to 2. Now, if you were being a little bit less than exact and you used the x1 value down here as the 0.785 instead of the actual pi over 4, the values might not look like they're actually getting closer to 2 as you go down your table. But they still look like they're close to 2, right? All right, so the values here are supposed to actually be getting closer to 2, and the more precise and exact and detailed you are, the more reasonable that looks. But the slope here actually does equal 2. But again, just like last time, we haven't really proven that that's the case. We've just approximated it. So the slope is approximately 2. Was everybody okay with finishing filling in that table? Again, it doesn't have to look just like mine, but it still should have the sense that all the values were fairly close to 2.
It's part of a homework assignment that's due. Do you want it on this paper that we print out?
Yes, but this isn't really a homework assignment. I just wanted you guys to finish filling in
Okay.
that piece of it so that we didn't have to go through all the details because you knew what to do on it
Okay.
already. Yeah, that's a good question, Jade. Yes. The only homework that you're going to turn in is when I do collect it, is the homework that's listed on the bottom of the sheet.
Okay.
Those are going to be the homework problems that could be collected, okay? That's a good question. All right, so one of the things, again, then we were looking at last time, these were two different examples of calculus. Example 1 and 2 actually were the same type of example, right? They were looking at this idea of approximating the slope of some kind of a curve. And people do this in real life all the time. Have you ever been to Colorado and seen it say something like the grade of the road? They're talking about the slope, how steep something is. Obviously, that road is not straight. It's curved. In fact, it's three-dimensionally curved, so it's not even quite what we're doing here. But it has that same sort of feel to it. There's some sort of a curvature involved, and we're trying to find slope. So there's this limiting process going on. All right, there's another one that we're going to look at, just another brief example where we can use numerical approximation to what's going on. This is the idea of taking a curve and finding how long that curve is. Now, if the line were straight, you could just use the distance formula and you could find that, right? But we're not working always with straight objects. We're working with curved objects. So one way of dealing with this with calculus is to actually take the interval that we're looking at this curved object over and to sort of cut it into smaller pieces. We can take each of those smaller pieces and find the length of it as though it were a straight line, and that's a way to approximate the length of the curve. Is everybody sort of with me on this? The idea is basically taking our curve and splitting it up into little bitty line segments and finding those distances. So the first one that we're going to look at, we have the curve square root of x plus 1, and our interval is going to go from 0 to 3. Okay? Now the direction says that we're going to take this interval and we're going to first split it up into 4 segments, and then we're going to split it up into 8 segments. So I have a table for each of those. Here's the other table that we're going to fill in. So the first thing to sort of imagine is to imagine that x-axis, and that x-axis starting at 0 and going to 3. And if I need to split it into 4 pieces, I can split it into half, and then I can split it in those in half again. So if I split it in half, what's the halfway point between 0 and 3? 1.5, good. And then what's the halfway point between 0 and the 1.5? 0.75, very good. And then what about between 1.5 and 3? 2.25, you guys are on target today, excellent. All right, so these are the 5 x values that are going to go into our table. We're going to have 0, 0.75, 1.5, and 2.25. And then our last one's 3. Now the first one and the last one we can plug into this equation and we can get that answer really quickly. So let's just do the easy ones first. If I plug in 0 into f of x there in place of x right here, what do I get? If x is 0, what do I get? I get 1, right? Because I've got the square root of 0 plus 1, which is the square root of 1, which is 1. Is everybody with me on what we're doing? We're plugging that number in. It's kind of like what we did last time. It's just a different type of function. The other one that's really pretty clean to do is the last one, is 3. So if I put the 3 in here and then 3 plus 1, and then a square root, I get 2. Good. Now the ones in between, you're going to grab your calculator. Okay, so grab your calculator for me, and I want you to plug this in. So we talked about last time at least a little bit about your calculator, and did I actually talk in this class about how to use your tables? I don't think I did either. I did in my other class. I was running out of time here. I didn't want to belabor the point right now. So we're going to actually take a little bit of time and talk about your calculators. That's right. Many of you didn't have them. That was the other issue. I want to make sure you had them to be able to work with them. All right, so if you have a graphing calculator, that's the ones that I'm going to be talking to right now. If you've got a scientific one, you can just enter these. But I want to talk a little bit about how you can use your table in an easy way to do this, okay? So first of all, you need to make sure that your table is set up, all right? So if you hit second window, I think it is, you'll get a table setup menu. Does everybody see that? Do you have that? Okay, in that window it has independent and has dependent. Do you see those words, independent and dependent? Where it says independent, I want you to go over and make it say ask. The other one needs to stay auto. Okay. So the first line where it says independent should say ask, the second one should say auto. Everybody good with that? All right, also then we want to hit y equals, and you want to put this function into your calculator if you haven't already. So hit y equals, put in square root of x plus 1. Is everybody good? Excellent. Last thing you're going to do is you're going to go into the table, that second graph. And you can actually enter into the table underneath that x column all of the different x values that we have. And then you don't have to do all the keystrokes to keep entering the function over and over again. So that's pretty nice. All right, so we're going to we have the 3 in the middle that we still haven't written down, and I'd like for you guys to give me the values. We're going to go ahead and try to do 6 values this time. Again, if you want to do 4 on your homework, that's fine. But just so that we're all doing the same thing, let's do 6 this time, all right? So what do I get when I use 0.75? What's the y value?
1.3229.
Okay, let's do 6 values, though, because that's what I was just using.
Oh, sorry.
It's okay.
It was just how that was.
Yours. Oh, and let me just take that into. I'm glad you actually said that. Your screen only shows so many wide.
I can give you that.
And do you know how to do that?
Yeah, I'm sorry.
No,
Yeah.
you're fine. Don't apologize, because I want to make sure everybody does know how to do that, especially if they're not familiar with that table feature. So if you're wanting more accuracy, if things aren't turning out quite right, you can actually go up to wherever that number is in that table. Move your cursor up on top of it, and then the full number will display at the very bottom of the screen, at least as full as your screen goes. And so it goes out to something like 9 or 10 decimal places. So, remind me your name.
Zach.
Zach.
Yeah.
Okay, so Zach, what's after the 22?
876.
876. Excellent. That's fine. What's the next one if you put in 1.5?
1.581139.
Okay, did we have a second on that? Does that look good? Okay, what about the third one? Did anybody get that one yet? I'm guessing it's 1 point something.
1.8027756.
Okay, so 775 or 6 at the end if you run around, it's fine. All right, so this is what I've got so far. Does that look all right to everybody? Again, your value at the end might be rounded differently. That value, whether it says 5 or 6 on that one, for example, it's not going to affect the grand total of what's going on. So we're okay with it. So now it's time for a little bit of memory recall. Do you remember the distance formula? Perfect. Way to go. All right, this look familiar? Okay, good. This finds the distance between 2 points, right? Now we have 1 point. Actually, we've got 5 points on this graph, right? Or this table so far. And if you'll notice, just look at the x values for a moment. All of these x values, if you take 2 successive x values, what do you notice? They're always 0.75 apart. We did that on purpose, right? We made that decision up front. the reason I mention it now is because what that means is when you're doing the distance formula, you don't have to put those values in every time. This piece right here says I want the difference in two of the x values. Well, you know what that is. It's always 0.75. I don't have to enter the values. It's part of what's going on that's not going to change. So one of the pieces of this is simply 0.75 squared. That's kind of nice. The other piece of this will be different. Those y values are not equally spaced. Okay? So we're going to take the first two y values, and there's actually something really nice about this formula. It's not quite the same as when we did slope. The nice thing about this formula is that each of these things are squared. What happens when you square a number? You always get a positive number. That's kind of nice. And the reason that's kind of nice is because it means that it doesn't matter the order in which we subtract these guys. If I subtract the 1.3 minus the 1, or I subtract the 1 minus the 1.3, and then I square each of those values, I get the same result. So you don't have to be so careful about putting it in the right order because it's not going to affect the answer. Are you guys tracking with me on that? Does that make sense? If you want to be extra careful and put them in the right order, that's fine. But it doesn't really matter on this particular equation or formula to do it in a specific order. So what I'm going to do is I'm going to actually put in, that's not what I want to do. That. I'm going to put in the 1.322876 minus the number 1. Now, as you're doing this, be careful where you put the squared, right? The squared needs to be outside the parentheses. Be careful that the square root is around everything that's inside the parentheses and so forth. And what this is actually going to give us, this line is going to be blank because I'm going to take that number to the previous point. There isn't a previous point. That's the first point. So the value that I'm going to get out right now is going to be in the second spot right here because that's going to be the distance from this point to that point above it. All right, did you guys get a value yet? I've seen some of you working on the calculator on this.
Yeah, for the first one I got 0.458251.
Did I write that down right, Zach?
Yeah.
Okay, did anyone else have that same value? The value I have written on my paper is different, but I might just have an error in what I've done that I need to know.
I got something different.
What did you get?
0.816547.
Okay, so let's double check your entry in that one. Because that's the answer that, is it Nathan?
Awesome.
Austin, I'm sorry. That's what, Austin's value is the one that I had written down as well. So double check for me, Zach, and make sure that you don't have a parenthesis going wrong or a sign wrong maybe. Does anyone else have this value, the 0.816 value? Yeah? Okay, so here's the cool thing now. As you go to the second value, what you need is you need the distance between these two values, the 1.3-ish number and the 1.5-ish number, right? Well, the 1.3-ish number is already here. So you need to replace where the 1 is with the 1.5-ish number. That's going to give you the distance between those two, and then when we square, it's going to become positive. So again, the order doesn't matter. So as you enter this now, what you're really going to do is you're going to change this number right here, and in that place, you're going to write in the 1.581139 and do your subtraction. Now, on most curves, this is not going to be the same answer we got before. It would be unlikely if it were. In fact, if it were, it would mean that you were starting with a line, and at least in most cases. And in this case, you're certainly not doing a line. This is a curve. You know that one is not a line because it's got that square root in it. So what did you get for this particular distance?
0.793221.
Yeah? Is that what everyone else has? This is yes. Like this? You do your head like this. Yeah? Okay, good. Good, good. All right, so we're good. And Zach, you got the calculator working for you now? You found the error. Perfect. You know what? That's kind of interesting. Like right here, you put the subtraction.
Yeah, I don't know why.
That's
I just
okay.
wrote it down.
I had done that yesterday when I was teaching this part of the lesson to my other calculus class. I had a sign error there, so you're in the same boat as I am. So you're in good company. Yeah, excellent. Okay. So now we're going to take our values that we have, and if you're working on this, you can replace this number now, right? Because now I want the difference between the 1.8 and the 1.5. Well, I've already got this 1.5, so I could put this in place of the 1.8. Again, I could switch the order. It doesn't really matter. But I need the 1.8 number and the 1.5 number to be in that second part of the formula. All right, did you get a value? What do we have?
78206.
Is that all good? That's what I have written down too. Excellent. All right, we have one last one to do. The last one to do is to replace this number 1.5 down here now with the number 2, right? Because we want the difference, or the distance, excuse me, between the 1.8 and the 2. What do you guys have?
.775498.
All right, so visually what's going on is this. Just in case you haven't thought about this graph in a while, the graph looks basically like that. It's not very curved. Let's try that. And we've split it up, and we've taken the numbers from 0 to 3, and we've sort of broken this apart into pieces. Roughly like this. And we have decided to take this point and find the straight line distance between them. And the straight line distance here, here, and here. Is that good? So how do I find the full distance using this method from 0 to 3? You add them together. And your calculator doesn't have any problem adding these funny long decimals together, right? So go ahead and do that. So you're going to add together everything that you have in the last column, from the 0.816 down to the 0.775. And the reason there's 4 is because there were 4 segments that we used. The length is going to be approximately the sum that we get from those 4 distances. And what is that value? And I'm going to stop with the 4 decimals because we're aware that as we got towards the end, some of our roundings are going to be a little bit different. So 4 decimals of accuracy for the final answer is perfectly fine, and that's consistent with what your book's going to do. Okay. All right, so what's going to happen on the other half of this problem? What am I supposed to do for the other half? Do it in 8 segments, right? But haven't we already done 4 of that? At least the x and y values? We have. So if you take a look at this over here, we had already found out that this is 0, 0.75, 1.5, 2.25, and 3, right? And we found the y values that corresponded to that. We found this to be 1. This one was 1.322876. This was 1.5. 581139, 1.802 776, and 2. I just need to split those into smaller segments now. So what's halfway between 0 and 0.75?
137.
0.375, yeah. What's halfway between 0.75 and 1.5? That's probably not one you have in your mind. We were almost working with money before when we were looking at the numbers. Now all of a sudden we've got 3 decimal places. There's no money comparison here exactly.
1.1.
And how did you get the 1.125 in case someone's curious?
I added the 0.75, the 0.375.
Okay, so you recognize that the difference between these is all going to be 0.375. Absolutely, you can do that. So we can take the number before and simply add the 0.375 to it. Did anybody do it a different way?
Don't you add the 0 and 0.75 together and divide by 2?
That's another way to do it, all right? So if you want to, you can take the 2 numbers that are going to be the end points, basically, and to find the number between them, you can add those 2 numbers together and divide by 2. And that will give you the number halfway between. So there's 2 different, those are distinctly different ways of doing the same thing. All right, so what is it that's going to be halfway between the 1.5 and the 2.25? Did you get one? 875. And then halfway between the 2.25 and the 3?
2.625.
All right, so we would fill this table out just like we did the other table, right? I kind of want to think that you guys can finish filling in this table on your own. Does that make sense? Because you have all those details already. Let me fill in the f of x values, and I'll let you find the distance values to finish that on your own later. The f of x values are 1.172604. You can get these straight out of your table. The next one was 1.457738. The 875 is 1.695582. And the last one that's missing is 1.903943. So in principle, what we're going to do then is we're going to use the distance formula just like we did before. And then what are we going to do? We're going to add them together. But this time when we add them together, there's going to be how many numbers? 8. There's going to be 8. Remember, this first one will be blank because there is no distance from here to anything because there is no previous value that we're looking at. So there's nothing in this one. There will be the bottom 8 of here that you would add together. Does that make sense? All right.